I'd like to close off our discussion of payment systems with a brief description of a new type of decentralized public ledger-based system, which is not maintained by any institution or hand-checked by humans, what we refer to in modern terminology as the blockchain. Blockchains are generally open source pieces of software that are designed to prevent fraud by verifying changes across the entire network. There's a lot of complicated mathematics that usually involves trying to factor prime numbers involved in these sorts of so-called cryptocurrencies, but they have effectively been able to replicate for us the ledger-based payments transaction system that were previously created by the Sumerians. It's important to recognize right away that cryptocurrencies are ledgers. They're not actually physical tokens, which means that while we may be able to transact using them in some kind of limited fashion, they don't enjoy standing as a legal currency, nor is there any way for you to hold Ethereum or Bitcoin in your hand, aside from putting it onto a stick drive first. So it's important to know that while blockchains can be used for a variety of other things beyond simply payments, it's the payments application of blockchain technology that I'll be talking about for the next few minutes. Roughly speaking, cryptocurrencies work on the premise that each participant in the system has a private cryptographic key that can be used to unlock a fraction of the total value that's held on the ledger, enabling them to transfer part or all of their part of the ledger to someone else. This effectively works just like a farmer 5,000 years ago who has grain in a collective granary. By using the ledger-based system, we can transfer wealth that is being held collectively from one participant to another. Now, of course, processing these transactions requires computer power. There is still a matter of verifying all of the ledgers and all of the transactions to prevent fraud, but this isn't done by humans. Instead, it's done by complicated calculations in what we call a proof of work system. For those who are crypto buffs, I am aware that there are other types of ownership verification, like say, rather than working on proof of work, there are other ways of determining how people ought to be rewarded for their participation in the system. Needless to say, to keep the matter somewhat non-technical, we'll focus on proof of work systems, since this actually represents the technique used in the original cryptocurrency, Bitcoin. Now, in a proof of work system, what happens is that computers all around the world who are hooked up to this network compete with one another to complete mathematical problems. The one that completes the mathematical problem enables the transaction to be completed, but also earns a reward for having devoted their computer energy to this type of problem that needed to be solved to enable the transaction to take place. This type of computerized math solution is what is often referred to as mining of cryptocurrencies. And it has shown that even though it used relatively little bits of power in its early days, today the power usage required to complete transactions on first-generation cryptocurrencies like Bitcoin is simply extraordinary. The amount of power being used by the Bitcoin network is in fact greater than the power consumption of some countries, making it desperately inefficient as a payment system. Furthermore, the original blockchain payment system, Bitcoin, suffers from serious bandwidth problems. There is a real tightness in the pipeline, and transactions can only be completed as opposed to in real time at specific points in time, and they simply sit on hold until the transaction can be completed. This, of course, creates drags on the system, but it's important to remember that this is only the first generation of this type of new technology. One of the weaknesses, of course, that comes along with cryptocurrencies is the possibility that their prices can be manipulated. The market for cryptocurrencies is not nearly as deep as the market for, say, euros or US dollars or Canadian dollars is. And in fact, there's good evidence to show that the bubble in Bitcoin in 2017 and 18, which subsequently collapsed, was in fact caused by a single party of people that had gotten together intentionally to drive up the value of Bitcoin and sell their own assets into the bubble. Now, aside from a speculative place to park your money, Bitcoin in and of itself might not be particularly impressive. It effectively represents the Windows 95 of blockchain payment systems. Nonetheless, there have been substantial improvements in just the 10 years that we've been enjoying the existence of cryptocurrencies, and we should expect more great things from them in the future. The global popularity of blockchains has exploded in the last half a decade, and there are a number of new kinds of networks being created all the time, from Ethereum to Lightning networks, etc., to try to improve the efficiency of the technology. Most importantly, this technology represents a very substantial improvement over the slower systems that we had for verifying large-scale transactions. And it's worth noting that a number of central banks around the world are considering the adoption of their own cryptocurrencies, not buying one that's on the market, but creating their own for purposes of national interbank transfers. So this type of technology, while it might not be used to pay for things like your cab fare or a drink at the bar someday, almost certainly will find their way into the back offices of large financial institutions and will have a revolutionary impact on the structure of interinstitutional payments, even if we never take a cab using Bitcoin.